All right, everyone, welcome to the afternoon session. For this particular one, we have with us Josh Mkhari, homegrown out of here, Joburg. For an intro, he told me to say computers seem to like him, apparently. He's going to take us through some event things. So let's have a round of applause for him.
Thanks, everyone, for coming by. So this will be on event-driven workflows, as I've titled it. And while I wait to remember what's on my slides, I'll just introduce myself. So I study computer science, and I'm currently working as a solutions architect at a documents warehousing company. But I say solutions architect in quotations every time because I don't feel like one all the time. But in any case, since I think my slides are on the screen, I will start the presentation as soon as I get rid of that. There you go. Anyway, so, you know what? This is pure demo life. Anyway, let's just go right into it. I'm going to ignore all of my WPS problems. So I have a very strong dislike for using Microsoft products. So I actually downloaded WPS literally yesterday, and now I'm like, I actually don't know how to use this. So I'm going to switch back to the actual, use like Canva or something instead, because I feel that's probably a lot better. Unless anybody actually already knows how to use WPS, and that would be pretty cool. But we'll see. Anyway, skip that slide. So let's get right into it. I found this meme, and I think it might be quite relevant to a lot of us. I don't know how many of us are data analysts here, but in my previous job where I was working as a data engineer, I remember many a time the data engineering team, would get into a lot of trouble with the other teams throughout the company because we, would promise that, hey, this table does exist. Hey, this table does have these columns that you bring up. But in reality, we're still trying to figure out what the source data even looked like. But over time, fortunately, problems like these have disappeared, right? So before we really get into it, has anybody here used Airflow before, Apache Airflow? Okay, well, at least a few of us have used it, but I'll still explain it. But Apache Airflow is an orchestration tool. So it's a data orchestration tool, one of the, I don't want to say archaic, but compared to newer tools we have now, like Dagster, it is a bit on the old side. But, coming from the Apache Foundation, it is really, really good, really useful. It's open source, it's free, anybody can use it, and I'll explain how that works when I get to it. But essentially, Airflow is, like I said, an orchestration tool, so it allows you to actually task items and have those items, work in a workflow. And this is all done through Python coding. So when I get to the actual user interface, I'll be able to better explain what a DAG looks like and how that actually works. But for today's actual presentation, what I'm really focusing on here is making your DAGs event-driven. So, first and foremost, there is a problem, and that problem is the hope and wait, as I like to call it. So, for those who don't know what a DAG looks like, it doesn't necessarily matter what framework or tool you're using. At the end of the day, a DAG will be a sequence of tasks that, come together to actually perform an actual, task, as it were. So in the data engineering world, let's say we're moving data from one database table to another database table, whether, let's say we're using medallion architecture, which is, I don't know, actually, do we all know the medallion architecture? I feel it's pretty popular. Okay, but in any case, in the data world, when you first ingest data, you ingest it into a bronze layer, then you move it into a silver and gold layer, and as it progresses between these layers, we're essentially refining and cleaning the data to a point where our end users, which would be using the gold layer, can actually use the data. So in any case, a DAG. What we have here are 6 different tasks. First task, which is called run me. We have 2 more tasks, also called run me. And what makes Airflow DAGs and DAGs as the concept really useful is the fact that in one of these tasks, you as a developer or the backend person can define what that task is supposed to do. So again, for argument's sake, let's say you are working in a sales company, or well, every company makes sales, but let's say you need invoice data, and the first task is just retrieving that data from perhaps Sage, for argument's sake. So that run me _0 would be that Sage task, the actual code to log into using the API, initializing, downloading said data. Then, as you can see, there's a little arrow that points to the next task in this DAG, and that's run after loop, as it's titled here. And let's, for argument's sake, that this run after loop depends, well, not argument's sake, but as you can see with these arrows, it does actually depend on run me 0 and run me 2. So this task can only run after run me 0 and run me 2. This is just like DAG knowledge. And this task here, the final task, can only run if these 2 tasks have run. So when we're talking about DAGs as a whole, we're talking about multiple tasks that perform something eventually. And they have different dependencies, and sometimes they just run simultaneously. But in any case, I'm just quickly rushing over this because this isn't the main point, but that is essentially what's meant by a DAG. And that is the bread and butter of Airflow. What Airflow was initially designed for is to create these DAGs for us developers to then use to accomplish certain tasks. So when I say the hope and wait problem, what I'm actually referring to is this problem that I've at least come across billions of times. But for instance, you are a end user. So let's say we're the CFO, and at 8 a.m. every single day, we're expecting some sort of report from our data teams that shows, let's say how many people, or actually how many sales we closed the day prior. So our data teams have this pipeline run at 3 a.m. every single day. So every single day, we have a DAG, which looks something like this, right? And it'll do a couple things. And when that DAG is done, we know at 8 a.m. we'll end up with a report for our CFO. But occasionally, bad things happen. Occasionally, as we all know, computers and code doesn't always like to play nice. So for argument's sake, at 3 a.m., this DAG was supposed to run, this pipeline. At 3:02, the data that it depends upon never arrived. Or maybe along the way, some error occurred. Maybe a server's not working. Am I actually using this mic? I don't think I am. No, it's fine. But for argument's sake, so they can't hear us right now. This is good, right? Do I need to do it again? Cool. So at 3:02, that data you realize never actually arrived because you ran into a problem. Maybe it errored out, maybe timed out. There's an infinite number of problems. But maybe your data team or your software engineering team has a lot of built-in checks and retry logic. So maybe the problem did occur, but at 3:05, the data did arrive. But unfortunately, your pipeline ran at 3. So now at 8 o'clock, your business user, the CFO in this argument, realizes there's no data. And now that means they have to wait for the next day before their pipeline actually runs. Or, of course, they can always just shout at a few people and get the data on time. But that is the hope and wait problem that Airflow was able to solve with versions 2.4 onwards. So just for code, to show you what the code used to look like, prior to version 2.4, when we wanted to schedule a DAG, so quickly going to slide back like 3 tabs, whenever we wanted to schedule one of these, you would have to explain to the code, with that line that this instance of code is going to run at 3 a.m. or it's going to run at 5 a.m. or it's going to run every 2 minutes or it's going to run at 3 a.m. every Monday, Wednesday, Friday or bi-weekly or sometimes, like these are all things you can do with these, with this top line of code here, the schedule interval. Those 3 asterisks let you actually, configure it in the way you'd like. But what's important is we now have this, the second bit, after 2.4. So you can still schedule your DAGs to run the way they used to, but now we have the ability to use something called a dataset. And that's actually the most important part of the talk. So you ask yourself, what is a dataset? So dataset are quite literally your events. So going back to my earlier example of where your CFO is waiting for this report at 8 a.m. and at 3 a.m. this pipeline is supposed to run with the data already there. Instead of waiting, or no, I shouldn't say waiting. Instead of actually scheduling that pipeline to run at 3 a.m., it can instead run automatically when the data arrives. So it would run at 3:05 automatically. It wouldn't be something that some software engineer, data engineer, or anybody else had to guess, because initially we all assumed, by 10 p.m. the day before, all the sales should be done by 2 in the morning, all the calculations should be done, so by 3 a.m. our pipeline should work. But of course, like we all know, bad things happen from time to time. So this new dataset approach allows for things like, I don't know if anybody's used Apache Kafka before, but then there's a concept of producers and consumers. So with our datasets, we now create DAGs that work in the producer role and DAGs that work in the consumer role. The DAGs in the producer role will, if we go back to this quick tab, which I think is becoming my favorite tab now, if you look at how we were depending on things here, in the past you might have had 4 or 5 different DAGs that all do different things at these different times. But now we can have one DAG to do the one job, and when that job is done, it will create a data set, which will then trigger another one of these, and will use that data set to continue its journey. So this actually solves the coordination issue, the lateness issues, the problems we've actually been the problems most companies still deal with. It also solves one of the larger server strain issues, because let's say, for argument's sake, instead of timing it for 3 a.m., the pipeline to actually run at 3 a.m., you thought it would be easier if you just let it check every minute, So after 3 a.m., if the data is not there, just check every minute until the data arrives. That in itself is a server strain. You're actually straining the server because now you have a worker assigned to doing this task. The same way, even in real life, I'd be pretty annoyed if I was asked to look out the window every minute for my delivery driver to arrive. That same concept also works within, our servers. We can't have them working constantly to no end, perhaps. Maybe the data never arrives. So data sets are quite literally the solution. So I'm going to just demo Airflow to show you how these data sets work. And we've already seen bugs with me just trying to get WPS to work. Oh, cool. I actually have a lot more time than I thought. So you already saw me struggling with my WPS install, but I think demos are a better way to give you an understanding of what not only Airflow looks like, but also how it actually works. So I set up this Airflow instance. It's Dockerized. I don't think I need to show you how the Docker works, but I can share that later. In any case, we have about 10 DAGs here. So I numbered them so we can actually see the progression of how each DAG works. But I'm going to open up this first DAG. There are some of us who haven't seen the Airflow interface before, so I'm going to quickly walk us through it. But essentially, it's a web user interface, and I now see that my time here is wrong because this is in a Dockerized container. But anyway, so we have this DAGs view. It shows us all the chunks of code we've already created that accomplish said tasks. I know in today's like modern time, I can call it that, there's new tools like N8N. I don't know if anybody has heard of that recently. And what it does is actually what Airflow's been doing, but of course it does it in a much more user-friendly way. Because with N8N, it's a drag and drop, very nice canvas. You can say, hey, I want to send an email to a person after I change a column in an Excel, and it's all drag and drop, no code whatsoever. But I want to assume because we're here, we're all Python enthusiasts, so we still enjoy the pain of struggling to code something. So with Airflow, you still have to go through those pains. But let's look at one of these DAGs. So we're going to focus on ingest sales data, one underscore ingest sales data. And as you can see here, you have a couple important views. You can say there's some runs here that shows you how many times it succeeded. We already have one here that failed. And we can also see the last time it ran, the next time it's going to run. So if you open up one of your DAGs, you've met with this view, but what's important for us would be the graph view, because that's where we see that DAG view I showed you earlier. So remember the example in that presentation, we had run me underscore 0 and all those other run me's, 6 tasks in total. This is a much simpler DAG. It only has 2 tasks. First task being ingesting data, and the second task being creating our said data set. So I'm going to show you the code to ingest this data, but it's a very simple script. All it actually is going to do is create a CSV file, because I wasn't sure if I'd be able to access my VPN from here. But irrespective, it creates a very small CSV file, which once created is saved as our data set. Once this data set exists, the moment it exists, our next DAG, which if you look over here, its schedule is called dataset. So these 3 here, they're all datasets. So our next DAG, DAG2, you'll see that its graph is a bit different because it's waiting for a dataset before performing the Python code. So remember the previous one, Python code first creates a dataset. This one, dataset exists, then Python, then another dataset. So we're chaining different activities together. So if I go back again, I am going to open up these on different tabs so you can see all the times as they move along. Let's go back here to this one. I'm going to run it. Well, when I manage to click on it, I'm going to run it. So I click run, and my task is started. So again, this could be something that you schedule. So currently it is scheduled as daily, and the next time it's supposed to run is apparently 2 in the morning in 12 hours. So automatically this would run anyway at 2 in the morning every day. But right now I just ran it for the demonstration. So you can see here under our DAG runs that, let me hit refresh. Anyway, but under our DAG runs, this is where, refresh, okay. So under our DAG runs, you can see that I ran it manually. See, manual run. I ran for about 8 seconds. And that means, if you go to our graph for this specific run, it means, a few seconds ago, this data set was created. Which means if we tab here and we hit refresh, this should be from a while earlier, 11:47. If we hit refresh, this should have ran automatically. So looking at this, it did run. If we go to the graph, it will tell us that it ran a minute ago, successful. Anyway, so this is the chain of events. So these are event driven. It's very important. You don't necessarily need to create files in order for Airflow to be event driven. So it's not required that you create CSV files like I am here for the demonstration. Instead, you can also just tag them as events. So for argument's sake, let's say you are part of a massive data engineering team and you need data for your machine learning model team and your machine learning ops teams to actually train a model and then run that said model. The engineering team would first create a massive DAG with multiple dependencies with a lot of calculations involved. That could take 2, 3, maybe even a whole 5 weeks for the data to be collected. It could be terabytes or even petabytes of data. And once that's done, instead of having to then, over a Teams call, over a message, explain to another team that, hey, this data is ready, you can now use it, you've already agreed on a data set methodology. So the next team wouldn't need to wait for any of that data to actually exist. The data set itself allows them to continue. So I've actually made one of those already. But essentially, number 7 here is the data engineering team. If I go to my graph, you'll see they prepare data. Again, I'm going to show you the code soon, but they prepare data. Once the data has been prepared, the data set's created, and automatically all the other teams, their scripts will run too. So you click that, it's going to prepare whatever data is needed for the team. The team will then, so this is the ML team. As you can see, it's now running because the data engineering team's task actually happened. Then after the ML team's task is completed, the ML ops team's task runs too. So remember, the data engineering team was a very simple graph, just quality checks, train model, then the fraud detection, for argument's sake. So this is all just examples, as it were. But this is all based on the data the data engineering team had already created. So the idea here is, with data sets, you're not limited to what you can do, and especially on computer constraints. That's like a very big deal. I've seen many servers at many of our clients that are just overstrained because instead of event-driven approach, the teams there have opted for manual every 2-5 seconds a check to see if something has happened, whether they're checking against an API or whether they're checking against an API or whether they're checking against an internal system. This is literally hurting your server. It's literally performing bad. It's bad data governance, as it were. So I'm going to quickly open up, let's say, ML ops team, for argument's sake. Let's go up with the graph. Actually, no, I think the one that had the 2 data sets instead of 1 is a better option. So let's just go back 1. Should have just gone to DAGs. Scroll ML team, I'm pretty sure. It's triggered by a data set and has another data set. So if we click on code here and we scroll through, so this is all Python. And of course, you'd probably just use VS Code right over here. But the Airflow tool lets you actually interact with your code, and you can also see what version of code ran at that specific time. So preparing training data, it's nothing serious. It's a CSV file for this demonstration. But it's all just simple Python code. These are things you can prompt your LLM to do for you. I mean, I'm not too much of a fan of LLMs right now because I actually have an Airflow script I use on my day-to-day basis. It reads my emails for me because I'm lazy. And as long as it's an internal email, it will reply to internal people automatically for me. And if it's not an internal email, I'll get a Telegram message because that's something I check all the time. But these are things you can do with Airflow and with event-driven scripts, essentially. I'm going to end there because I see my time is flying. Are there any questions? Yes.
So when you say that you get, so when you okay, so when you say that you automatically get it to reply to your internal mails, is it a standard response, or can you walk me through that?
I wasn't saying anything, don't worry. So how I've got it to work, I have a Gemma 3 and I'm using Ollama. So I have an Intel Arc A770, that's my graphics card, and I'm running that Ollama server at home. I feel I can probably, I'll connect to it afterwards, but anyway, what it does I'll show you here through a DAG. So let's do this. Please click graph, please. There you go. So the first step for me is it's using a sensor. So I couldn't use event driven there because Outlook would probably consider me a bot or something. So my sensor checks every single 10 minutes if I have a new email. If I do have a new email, it moves on to my next step. The next step is parse the email body, takes that body, pastes it into my curl response for my model. Then I've already trained, I don't want to say trained the model, but parameterized the system prompt to look for three things. One, is the email marked as high importance? If it is, I should actually probably read it myself, you know, as the actual human. If it's not marked as high importance, then it goes down a path of two more. So imagine more tags. Anyway, it goes on a different path. So that path is this email internal? If the email is internal, I'll let my LLM guess a response. And I limit the response to, I said, what, 20 words? That's what I just said, 20 words. And usually it's fine because for the most part, I'll be asked, hey, could you, check on one of the DAGs that's not working? Or, hey, one of our clients wants you to go to a meeting. And yeah, my LLM will just respond, yeah, I'll go to the meeting and blah, blah, blah. So what I do, because it's actually important, at the end of the day, it's the very last step in the DAG. It sends me a Telegram notification to say it replied to 8 emails. It will tell me, 3 of those emails were important, so I should actually go check those. And it gives me a slight, the subject heading for all those emails. So have I gone into trouble yet? No. So I think it's working well. But yeah, it's just something you can do with Airflow. You know, it's all Python, so it's easy to use. But yeah, we'll see. Maybe I'll tell you guys I'm in trouble.
Okay, anyone else? Okay.
I have to ask, why did you go with Intel for your GPU?
Right. So I had a GTX 1060 in the past. That was like 2017. It's because I was very avid on gaming. Then when it was time for me to update my graphics card because I like playing Risk of Rain, and now my graphics card was absolutely throttling. I saw that Arc had, so many, well, they call them, they're not CUDA cores, that's NVIDIA. I forgot what Intel calls them, but whatever cores. It looked like it was relatively comparable, so I thought I could either get it was an RTX 3060 at the time, or, I'm lying to you, it was RTX 4060 at the time, or I could get a Intel Arc A770, which on paper looked like it could be an RTX 4070. It was not. But it looked like it could be, So I just opted for that because, price to performance. And it also had 16 gigs of VRAM, which is hard carrying my LLM ambitions. Yeah. Yes, sorry.
Okay. I think this will be the last question. For anyone else, you can catch him after the session.
Hi. So firstly, very good talk. Secondly, have you used any other orchestration tools? I'm specifically looking at like Prefect.io and those kind of ones. And secondly, also, you said you haven't gotten into trouble yet. How long have you been using this?
I'll answer the first question. The second one first. It's been since it's October now, yeah. So I guess 5-6 weeks. Then it's been doing fine. And I do get a lot of emails. Like I'll show you. Like, so it's working fine. And I've only used Dagster as my other orchestration tool. And I tried N8N recently because drag and drop sounds like a lot of fun. Yeah. So I haven't tried that. Sorry.
All right, let's give a round of applause to our speaker. It's been wonderful having you.